All right, let's practice some equilibrium. Do some practice on writing the formula for a specific reaction. We'll do some calculating on finding the K constant. And we'll also just calculate some general equilibrium problems. So to begin with, we'll practice writing the formula because if you can't write the formula, then you can't really do any of the other types of equilibrium problems. So it's very important that you know how to write this formula out correctly. All right, so with that said, let's just jump straight into these problems, see what we can do. I highly recommend pausing the video, working the problems out, and then resuming the video to check your work. So our formula, if you don't remember, is K equals products over reactants. In this case, our products will be C raised to C, the concentration of C raised to C, times the concentration of D raised to D. Now C and D, these are the species, the chemical species on the right side of the arrow, the products, product chemicals. Lowercase letters C and D represent the coefficient of the balanced equation in front of them. Now our reactants will be A raised to A, concentration of A raised to A, times the concentration of B raised to B. Capital A and B also are the reactant species or the chemicals on the left side of the arrow, and A and B lowercase are the coefficients of the balanced equation. So now that we got our base formula down, let's figure out the specific formula for each individual reaction. So first up, we got 2NO plus O2 yields 2NO2. Always make sure, check your states of matter. This is a gas, and a gas. I'm going to use all of them. Then make sure your equation is balanced. This one is balanced, so we are good to write our expression or our formula. So K equals, what does K equal? That's products over reactants. Products are on the right side. So my first and only product is NO2. And looking for the concentrations. I'm going to express it in concentration. And I got to raise it to a power. Its power is its balanced equation right here. So that's going to be squared because it's 2. Now I do reactants on bottom. Reactants were the ones on the left side of the arrow, and I have 2 of them. So I got NO, so concentration of NO, and it is going to be squared times the concentration of O2, and it's just to the first since it does not have a coefficient, so it's generally understood to be 1, but if you want to, you can put a 1 there. And there is our first answer. Alright, let's do the next one. Got 4HCl plus O2 yields 2H2O, 2Cl2. Got gases, all gases, so I'm going to use all of them. Everything looks to be balanced, so let's get this thing underway. K equals products over reactants. My 2 products are H2O and Cl2. So I got concentration of H2O. It's raised to the second times the concentration of Cl2. And it is raised to the second as well. Reactant's going bottom, so that's going to be HCl. And this one is to the fourth because it has a 4 coefficient. Times concentration of O2, and it is to the first, so it's just a 1. And there's the equilibrium expression or formula for that one. Alright, let's look at the next one. Got calcium chloride yields calcium ions and chlorine ions. This one would be solubility equilibrium, but it still works the same way. I do notice there is a solid right here. Since there is a solid, it does not affect equilibrium. We leave it out of the expression, so I totally ignore CaCl2, just leaving me with 2 products. So K is still products over reactants, but since we don't have a reactant that we're going to use in the expression, K equals products. So K equals concentration of calcium ions, no coefficient, so it's just a 1, times the concentration of chlorine ions. It has a 2, so it's to the second. And again, there's nothing on bottom since calcium chloride is a solid. Next up, we got magnesium oxide plus carbon dioxide yields magnesium carbonate. I notice there's a solid here, so I'm going to eliminate magnesium oxide. Magnesium carbonate is a solid, so I'm going to eliminate it. So K equals products over reactants. There is not going to be a product. I only have one reactant. So K equals reactants, but in this case, K equals concentration of CO2. And no coefficient, so it's just a 1. All right, the last one. I got solid carbon, solid here, so we're going to ignore that one, plus carbon dioxide gas, plus chlorine gas yields COCl2, also a gas. So K equals products over reactants. My only product is COCl2. It is to the first. So that's going to be over reactants. CO2 is my first reactant. It is to the first. Chlorine gas is my second reactant. And it is to the second. So there is our formula. So writing the formula is pretty simple. Just if it's on the right side of the arrow, it's product. It goes on top of your formula. If it's on the left side of the arrow, it's reactants. It goes on the bottom of your formula. And any coefficient from your balanced equation is inserted into the superscript or the power exponent. Let's move on. So now we're going to practice just calculating for K. When you have equilibrium concentrations, you can solve for what K is. You can solve for that equilibrium constant. That way, if you change your concentrations initially, you can figure out what the equilibrium concentrations would be. So it says the following equilibrium concentrations, and that's the key word right there, equilibrium concentrations. That's how we know we're at equilibrium, because the concentrations are equilibrium concentrations. So the following equilibrium concentrations are obtained. I got 0.01 moles per liter of PCl5. So this one is 0.01 molar. Since it's in moles per liter, it is already in molarity. And equilibrium has to be in molarity or pressure. I got 0.15 moles per liter of PCl3. So this one is 0.15 molar. And 0.37 moles per liter of chlorine gas. So this is 0.37 molar. All right, so let's write our formula so we can solve for K. Well, K equals products over reactants. So my products are PCl3, and since I'm dealing with molarity, these are going to be brackets. Chlorine is Cl2, and both of these are to the first since they don't have a coefficient in front of them. It's going to be over the reactants. My reactant is PCl5, also raised to the first since it does not have a coefficient. Now I got my formula. I have information sorted out, so I just plug the values into my formula and do a little bit of math. So K equals concentration of PCl3 is 0.15 times concentration of Cl2, which is 0.37, over the concentration of PCl5, which is 0.01. So now we can simplify this down a little bit using our calculator. So 0.15 times 0.37 gives me 0.0555 over 0.01. So 0.0555 divided by 0.01 gives us 5.55. My value for K does not have a unit. It's just a number. Now you also might see a question in these, something along the lines of, does this reaction favor products or does it favor reactants? Since the value of K is greater than 1, this reaction favors products. If it were less than 1, it would favor reactants. Right. When equilibrium is reached for the following reaction, the concentration of dinitrogen tetraoxide is 0.050 moles per liter, and nitrogen dioxide is 0.1 moles per liter. What is the value for K for this reaction? All right. It says equilibrium is reached when we have concentrations. So we have equilibrium concentrations. Nitrogen tetroxide is 0.075. So 0.075 molar. Nitrogen dioxide is 0.1 molar. All right, let's write our formula. K equals products over reactants. My product is NO2. It's molarity, so I'm going to put brackets. It has a coefficient of 2, so it's raised to the second. My reactants is N2O4. And it does not have a coefficient, so it's just considered to be 1 or understood to be 1. Now we can just plug in our values. So K equals concentration of NO2 is 0.1, and it is squared. Concentration of N2O4 is 0.075, and it is to the first. Right, so 0.1 squared is 0.01 over 0.075. So we do 0.01 divided by 0.075, and we get 0.133. Repeating again, K does not have a unit, it's just a number. So our K value is 0.133. And since this K value is less than 1, this reaction favors reactants. Now that we got that down, let's work a general equilibrium problem. So we have a K value, we have some initial concentrations, and we're looking for the equilibrium concentrations now. So K equals 50. So I got a K value of 50. For the reaction A plus 2B yields 2C. It's just an arbitrary reaction, just kind of made up one. It's not a real one, but it still works out the same when you do the procedures. So I got A, which is a solid. I got 2B, which is a gas. And we're yielding 2C, which is also a gas. First thing I notice is this is a solid. I'm going to ignore it. Got 2B, which is a gas. I'm going to keep that. Got 2C, which is a gas. I'm going to keep that. And since these aren't real reactants, or since these aren't real species of chemicals, we have to assume this balanced equation is correct. So these coefficients should be fine. All right, in order to solve for equilibrium concentrations when we have initial concentrations, we have to use an ICE table. So let's set that up. So I got ICE. Initial, change at equilibrium, equilibrium equation. And some people also call this a Rice table, R would stand for the reaction. So initially, I have a concentration for B at how much? Well, it says I got 20 moles of B in a 2-liter container. Well, we have to have molarity. Molarity is moles divided by volume. So 20 divided by 2 is 10. So B is 10 molar. All right, doesn't say we have any C initially, so we're going to assume this is 0 molar. Now we do have 15 moles of A, but since it's a solid, it really does not matter. So we're looking for how many moles of B are left at equilibrium, which is to say, what is the equilibrium concentration of B. All right, so next is C, which is the change at equilibrium. Remember, reactants are minused by an amount. That amount is what we're looking for. The coefficient tells us how many times that amount is lost. So it has a coefficient of 2, so it's lost by 2 times the amount. Products are always gained by that same amount, which we don't know. coefficient tells us how many times that amount is gained. So this one is gained 2 times the amount. Just a quick little recap of how to do that, just so we're clear. Reactants always are minus and they always have an x. Coefficient tells you how many times it's multiplied. Since there's a 2, it's multiplied 2 times. Products are always plus and there's an x. Coefficient tells you how many times it's multiplied. In this case, it's multiplied 2 times. E is the equation at equilibrium. To get E, put I and C together. So 10 minus 2x. And the next one is 0 plus 2x, which is 2x. Alright, now we got our ice table done, we can write our equilibrium expression and solve for x. So K equals products over reactants. My product is C, and it is squared because it has a coefficient of 2, over the reactant, which is B. And again, it is also squared because it has a coefficient of 2. And there is no A because it's a solid. So we plug in our equations at equilibrium into our formula. So concentration of C at equilibrium is 2x. And again, it's squared. Concentration of B at equilibrium is 10 minus 2x. And it is also squared. Now we can simplify this down. 2x squared becomes 4x squared. Ten minus 2x squared. Looks like we need to FOIL that. So let me slide down a little bit so we can do that. So 10 minus 2x times 10 minus 2x. So 10 times 10 is 100. 10 times negative 2x, negative 20x. Negative 2x times 10, negative 20x. Negative 2x times negative 2x is negative 4x squared. Sorry, positive 4x squared, because a negative times a negative makes positive. So add like terms, 100 minus 40x plus 4x squared. So this equation goes under 4x squared now. So 4x squared minus 40x plus 100. All right, then we have a K value. K value is 50. So what we have is 50 over 1 equals 4x squared over 4x squared minus 40x plus 100. Let's cross multiply. 1 times 4x squared becomes 4x squared. Cross multiply again. 50 times 4, 200x squared minus 50 times 40x. It's 2000x. And 50 times 100 is 5,000. Alright, we add like terms, minus 4x squared, that cancels, minus 4x squared gives me 0 equals 196x squared minus 2000x plus 5,000. It's like we got a little bit of quadratic equation to do. So I like to label my quadratic equation values. So this is A, B, and C. If you don't remember quadratic equation, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So now all we got to do is take these values for a, b, and c and plug it into our equation here and solve it out. So I got negative b. Well, b is 2,000, negative 2,000. Plus or minus the square root of b, which is again, negative 2,000 squared minus 4 times A, which is 196, times C, which is 5,000, over 2 times A was 196. All right, let's see if we can't simplify this thing down and make it a little bit more clean looking. Negative times negative makes positive, so this is positive 2,000 plus or minus square root 2,000 squared is 4 million. And since we squared it, it becomes positive. Minus 4 times 196 times 5,000. I get 3,920,000 over 2 times 196, which is 392. All right, let's continue to simplify this down a little bit more. So I got 2,000 still, plus or minus the square root. 4 million minus 3,920,000 gives me 80,000 over 392. So the square root of 80,000 is 2,000 plus or minus 282.84 over 392. All right, so we're almost at the end here, so just hang on just a little bit longer. So I got 2,000 plus or minus. Now in the last lesson we said it's generally not the equation where you plus it in equilibrium, because it's going to make your molarity end up being negative. It's usually going to be the value which you subtract. So I'm going to do 2,000 minus 282.84 divided by 392, and I'm going to get an x of 4.38. So now that we got x, we go back to the beginning. So I take my 4.38 and I want to go back to the equation at equilibrium. I want to go back to this E row. I got 10 minus 2x and 2x. We just found x to be 4.38. So now we can do that math there. All right, so I got 10 minus 2 times 4.38. So 2 times 4.38 is 8.76. So that leaves me with 10 minus 8.76. So 10 minus 8.76 gives me 1.24. 1.24 molar. So there's that answer. Now we don't have to solve for the molarity at equilibrium for C, but we're going to anyways, just for good practice. So it's just 2x, 2 times x. We said x was 4.38, so it's 2 times 4.38. So molarity for C at equilibrium is just 8.76 molar. So there's that value. And now our question asked, how many moles of B are left at equilibrium? This is concentration of B at equilibrium. We're looking for moles. So if you remember, to get moles for molarity, we can just use the molarity formula. So molarity equals moles over volume. Well, the molarity is 1.24. I'm looking for moles, and volume is 2 liters. Put that over 1. 1 times x is 1x. 1.24 times 2 is 2.48. Divided by 1. X equals 2.48 moles. There is our actual final answer. So the moles left at equilibrium for B is 2.48. I know that's a whole lot of work to go through, but once you get practicing it, it's very quick or can be very quick, and it gets a little bit easier. So make sure you always practice, even though it looks daunting. All right, let's do another one. For the reaction, carbon plus oxygen yields carbon dioxide. Find the moles of carbon dioxide at equilibrium. Initially, there's 100 moles of carbon, 50 moles of oxygen, and 2 moles of carbon dioxide in a 2-liter container. So we have a K value of 2.5 times 10 to the negative 6. Our reaction is carbon with solid plus O2, which is a gas, yields CO2, which is also a gas. I'm going to ignore this carbon completely since it's a solid. So let's find these initial concentrations. So there's initially 50 moles of oxygen, and it's in a 2-liter container, so 50 divided by 2 is 25 molar. Carbon dioxide is 2 moles in a 2-liter container. 2 divided by 2 is 1 molar. Now to find the change, we always minus reactants by a certain amount of X, and the balance equation coefficient tells us by how much. Since there's no value here, it's considered to be 1. For CO2, it's a product, so it's always plus by the X amount. Balance equation coefficient tells us how much, so it's just a 1 since there's no value. E is the equation at equilibrium. To get E, we put I and C together. So 25 minus 1x, and I got 1 plus 1x for CO2. Now we got our ice table, we can write our formula. So K equals products over reactants. Only got one product, that's CO2. And it is to the first. Only have one reactant since carbon was canceled out due to it being a solid, and that is oxygen. And it's to the first. So now we can plug in. K is 2.5 times 10 to the negative 6. I'll put that over 1. So equal to the concentration of CO2 is 1 plus 1x. And concentration of O2 is 25 minus 1x. Alright, there's our setup. But there's a shortcut. Since the K value is so small, this is going to favor reactants. When the K value is as small as it is, you can ignore the X on the reactant. So what that means is I'm going to take the sign, the number, and the X, and I'm going to be done with it. Because the change in my reactant is going to be so small, it's not really going to be significant. Alright, now let's do a little bit of math. So 1 times 1 plus 1x is 1 plus 1x equals 2.5 times 10 to the negative 6th times 25 is 6.25 times 10 to the negative 5th. Now let's add like terms. Subtract 1, subtract 1. So 1x equals negative 0.999. Divide by 1. X equals negative 0.999. Now we got x, we can go back up to the top and plug into our equation at equilibrium. Now this is the first time we've had to deal with a negative, but that doesn't really change anything. What's going to happen is since we already have some product initially, the negative is going to cause it to lose molarity and shift towards making more reactant. So let's see what we can't figure out here. So for the first one, 25 minus 1x. 25 minus 1 times negative 0.999 gives us 25.999 molarity. So the concentration of O2 at equilibrium is 25.999. Now for CO2. So that's 1 plus 1 times x, which is 0.999 negative. And that's going to give us 0.001 molar. So the concentration of CO2 now is going to be 0.001 molar. See, our reactant didn't change a whole lot, but our product did. It almost went away completely. Alright, let's take a look at the next one. So for the reaction, 2SO3 yields 2SO2 plus O2. At the start of the reaction, there's 8 atmospheres of sulfur trioxide. How much sulfur dioxide and oxygen gas will be at equilibrium? The Kp, or the K constant, is 2.0 times 10 to the negative 6th. Alright, our K value is 2.0 times 10 to the negative 6th. Now, you see this P here. P means pressure, so we're doing pressure equilibrium. Also indicated by the atmospheres of our initial amounts. So our reaction is 2SO3. It's a gas. Yields 2SO2, also a gas, plus O2, which is also a gas. So everything's going to be used in this one. So initially there's 8 atmospheres of sulfur trioxide. So I got 8 ATMs. There is no mention of any initial concentrations of our products, so they are just 0. So our change at equilibrium, reactants are always minus by x. The coefficient tells us how much, so there's a 2. Our products are plus by x. The coefficient tells us by how much, so there's a 2. And this one is plus 1x. Our equation at equilibrium is 8 minus 2x, 0 plus 2x, so just 2x, and 0 plus 1x, so just plus 1x. Now we can write our equation. So K equals products over reactants. We use parentheses this time since it's pressure. So SO2 and it's squared times concentration times the pressure of O2 to the first over the reactant SO3, and it's also to the second. Now we can plug into our formula. So I got K is 2.0 times 10 to the negative 6th. Put that over 1. So equal to SO2. SO2 pressure is 2x, and it's squared. O2 pressure is 1x. SO3 pressure is 8 minus 2x, and it is also squared. Now, since that K value is so small, we can do a shortcut. If it's 1.0 times 10 to the 5th or somewhere in that area, you can ignore the x on the reactant. So again, what I'm going to do is ignore the sign, the number, and the x on the reactant, and only the reactant. Because the change on the reactant is going to be so small, it's going to be insignificant. Alright, let's simplify this down. So I got 2.0 times 10 to the negative 6th over 1 times 2x squared is 4x squared times 1x over 8 squared. 8 times 8 is 64. Let's reduce this down a little bit further. 4x squared times 1x becomes 4x cubed. Now we cross multiply. 1 times 4x cubed is 4x cubed. It's equal to 2.0 times 10 to the negative 6th times 64 is 1.28 times 10 to the negative 4th. Divided by 4. 4 cancels. X cubed equals 3.2 times 10 to the negative 5th. Take the cube root of both sides, and I get 0.032. So our x is 0.032. I can go back to the beginning to our equations at equilibrium to find out how much sulfur dioxide and oxygen there will be at equilibrium. So just go to your X and plug it in. So the first one we can do is oxygen. It'll be the easiest. 1 times X, so 1 times 0.032 is 0.032 molar. The next one, 2 times 0.032 gives me 0.063 molar. Now we didn't have to find SO3, but let's just do it anyway. So 8 minus 2x, and well, we know 2x is 0.063. So 8 minus 0.063 gives me 7.94 molar. And there's that answer. Alright, let's do one more. So for the reaction, nitrogen gas plus oxygen gas yields 2NO. The equilibrium constant is 6. The 5 moles of nitrogen and oxygen are placed in a 2-liter container. What are the concentrations of all reactants and products at equilibrium? Alright, so our K value is 6, so that means no shortcuts. Our reaction is N2, which is gas, plus O2, which is a gas, yields 2NO, which is also a gas. So we're going to be using every species. Initially, 5 moles of nitrogen in a 2-liter tank. 5 divided by 2 is 2.5 molar. 5 moles of oxygen gas as well in a 2-liter tank. So that is 2.5 molar. And no nitrogen monoxide was mentioned. So just 0 molar. So to change at equilibrium, reactants are minused by X amount. Coefficient tells you by how much. Reactants are minused by an amount. Coefficient tells you by how much. Products are plussed by an amount. Coefficient tells you by how much. The equation at equilibrium, 2.5 minus 1x, 2.5 minus 1x, and 2x. Alright, we can write our formula. K equals products over reactants. Our product is NO, and it is squared. My reactants are N2 and O2, and they are 2 of the first. Now I can plug in for my formula. K is 6, I put that over 1. NO is 2x, and it's squared. N2 is 2.5 minus 1x. O2 is also 2.5 minus 1x. So that's essentially 2.5 minus 1x squared. So it looks like we're going to have to do a little bit of FOIL to figure out this portion of the equation. So 2.5 minus 1x times 2.5 minus 1x. 2.5 times 2.5 gives me 6.25. 2.5 times negative 1x, negative 2.5x. Negative 1x times 2.5, negative 2.5x. Negative x times negative x is positive x squared. So this becomes then minus 5x plus x squared. So we take this and replace it in our equation. So I got 6 over 1 equals 4x squared now, because 2x squared becomes 4x squared. And this will be x squared minus 5x plus 6.25. Cross multiply. 1 times 4x, 4x squared, 6 times x squared is 6x squared. 6 times minus 5x is minus 30x. 6 times 6.25 is 37.5. Add like terms, minus 4x squared, that cancels, leaves me with 0. Minus 4x squared is 2x squared minus 30x plus 37.5. Alright, now it looks like we got quadratic equation coming up, so this is going to be A, B, and C. Quadratic equation again was negative b plus or minus the square root of b squared minus 4ac over 2a. So let's take our values that we labeled and plug it into our quadratic equation. So negative b is negative 30 plus or minus the square root of negative 30 squared minus 4 times a, which is 2, times the c, which is 37.5. That's going to be over 2a, which is times 2. Now that we got that set up, let's do some math. Negative times negative makes positive. Positive 30 plus or minus the square root. Negative 30 squared becomes 900 minus 4 times 2 times 37.5. That gives us 300. It's going to be over 4. Continue to simplify down. 30 plus or minus the square root of 600 over 4. Square root 600 is 24.5. So I got 30 plus or minus 24.5 over 4. Now, like we said earlier, when you do the value plus version, it comes out to be a negative molarity and it usually doesn't work. So we're going to stick to using the subtracted version. So 30 minus 24.5 divided by 4 gives me 1.38. So x is 1.38. So taking that value, we go back up to the top and figure out what x is at the equations for equilibrium. I'll start with NO first. So I got 2 times 1.38, and I get 2.75 molar for nitrogen monoxide's concentration. Next, I'm going to do nitrogen and oxygen at the same time since they are the same equation. So 2.5 minus 1 times 1.38, 2.5 minus 1.38 gives me 1.12. So these are both going to be 1.12 molar. And there is our answers. Equilibrium takes a lot of work, takes a lot of practice. There's a lot of steps. Sometimes the math can be complicated, sometimes it may be easy, but there's a lot to it. Make sure you practice each step so you can work your way through this nice and smooth, so that way you don't trip up on your test and do poorly. Practice is key with equilibrium. There's a lot to it, like I said. So as always, hope this video helps, and good luck on those tests.